In today's lesson, I am going to walk you through how to write fragmentation equations for mass spectroscopy questions, as well as understanding just the general structure of a mass spec graph in terms of, what fragment peaks are and what the molecular ion peak is, and then how we can use the different fragments to build a picture of what the molecule looks like. So we've got three examples to go through today. So let's take a look. It says the mass spectrum of compound X, C5H10O2, is recorded. The peak heights of M and M+1 are 22.65 and 1.25 respectively. Use the data to show that there are 5 carbon atoms present in one molecule of X. So I think a good point would be to discuss what M means. M is the molecular ion peak. And quite simply, it represents the mass of the whole molecule. So in mass spectroscopy, the molecule passes through the machine and gets split into pieces called fragments. However, some of it slips through the net without being broken into any pieces, so completely unscathed, other than the fact that it has a positive charge. So that peak there, if I do a little sketch, you always have like percentage abundance on the y-axis, and then the mass to charge ratio on the x-axis, and then the very last peak is always the one at the end. That represents the molecular ion peak, which is the mass of the overall molecule. Why is it the last peak? Because it's the heaviest. The molecule is unbroken, and then usually right after it you have this tiny little small peak next to it, which is the M+1 peak. And the reason why that is because of the presence of, in this particular case, carbon-13. In all sort of natural substances containing carbon, carbon-13 makes up approximately 1.1% of the total carbon. So it's majority carbon-12, but there will be 1.1% carbon-13. So we can use that information using this simple equation I'm about to write down to work out or prove a certain number of carbon atoms in the molecule. So what is the formula? So make sure you've got your calculator to hand, put in those numbers in, and this is what it gives me. So we can see roughly, to one significant figure, it would be 5 carbons. Okay, the mass spectrum has a peak of MZ57. Complete the equation to show the fragmentation of X to produce this peak. Most of the molecule will be broken into pieces, and those pieces are called fragments, and the fragments that are detected always have the positive charge, and the other part that is not detected is neutral. It's just a radical with an unpaired electron. So we've got to work out what C5H10O2 splits into to produce 57. For example, we could have, so that formula there, C5H10O2, suggests it could be a carbonyl compound, C double bond O, C single bond O with some carbons. This could be a carboxylic acid where, so we've got CO and then COH, so that too would produce 57. If we went with that one, C2O2H square bracket. Now this is the fragment that's being detected, right? So you have to put a plus charge there, which means the other bits left over, which is going to be, what have we got left? We've got C3, we've got H9, sorry, O. So what I've done, I've just subtracted what I've got left. So 10 hydrogens, 2 oxygens. And then we put a bracket on that, and then we indicate with a dot. So the dot means an unpaired electron. So it's a radical, but it's not charged, okay? So normally, you also see this in exam papers, so it's worth noting, is just going to redraw this one again, and you'll see it written as a plus and a dot. Now, why is it a plus and a dot? Because in the mass spectroscopy machine, the very first thing that happens to the molecule is that it's ionized. So an electron gun is fired at it. It knocks off a single electron, which, if you think about it, if all of the electrons are paired up in covalent bonds or lone pairs, if you're taking one electron off, somewhere in that molecule there will be an unpaired electron, which is that dot. And then, of course, the fact that you've ejected a negative charge, so you're going to be left with a positive charge. So that's why we have this dot plus notation. Okay, finally, we have a benzene organic synthesis. And it says the mass spec of P contains a molecular ion at 134. So that statement there immediately tells me that the mass of the molecule is 134. So that's the whole thing. And then it has major fragmentation peaks of 105 and 77. identify the species responsible for these peaks at 105, and write an equation for the formation from the molecular ion of the species responsible for these peaks. We know the overall molecule is 134, so that's the benzene ring plus the CO, CH2, CH3. But what we don't know is what this number represents and what this number represents. So how do we work it out? Well, there's always going to be a bit of trial and error with this. Fragmentation has to take place where you can see sort of a clean break. So an obvious one for me would be, if I just actually draw the molecules, it's a bit more clear for you to see. One obvious one that comes to mind is, and we just think this one aloud, we'll do it together using this sort of trial and error approach. So if I break it there, I'm left with a benzene ring, a C double bond O, and an oxygen, and the oxygen. So what does that come to? So we got benzene, which is C6 and 5 hydrogens attached. So 12 times 6 is 72, plus 5 hydrogens takes us to 77, plus 12, plus 16 takes us to 105. So this bit, that fragment, is equal to 105. What about 77? Well, I can clearly see that's a CH2, CH3, and that does not equal 27. That does not equal 77. That's going to be 29. So that means we have to break the molecule down in another place to create 77. We've already done a break on the blue dotted line. So maybe now let's, again, indicate this with different colors so you can see what's going on. So maybe we take a break down there. So that's going to leave us with this bit. And then the C double bond O has come off with the CH2, CH3. So let's see what that adds up to. 57. So that doesn't work because we need 77. Let's try something else. So that bit is 57. But what about what's left there? So let's add this up. So there is our answer. So that fragment is C6H5. So we have identified the two fragments that they want. Finally, write an equation for the formation from the molecular ion of the species responsible for the 105 fragment. So this one. So I'm going to use this notation with the plus and the dot, as that's the correct way to do it. Right, I hope that was helpful. I've linked the next video on this topic in the description below, so go and check that out now. And thanks for watching.